Good morning. Welcome to Stats Garage. This is going to be an example of a single sample test using the z-test. All right, so here's the situation. Let's say that we have a certain IQ test that we know the population of individuals as a mean of 100 and a standard deviation sigma of 15. We're interested in whether psychology majors are of average intelligence or not. All right, so let me say that again, right? We want to see if psychology majors are different. So I'm going to write that down here like that. To do this, let's say that I go out and get a sample of 36 psychology majors. And from this sample of 36, we're going to get an X bar, we're going to get an S, a sample mean and a sample standard deviation. But I want to leave these aside. I don't want to talk about these now because they're really not relevant yet. We don't need to know the results of the sample until we get to the third step and we are calculating the sample statistic. So where do we start? Let's start with the hypotheses. First step in hypothesis testing is stating the null and stating the alternative. I'm interested in speculating about the population mean mu for psychology majors. We don't know that one. That's the one that's unknown. But we do know on this test what the definition of average is. So according to the null hypothesis, if psychology majors are not different, then the mean for the population of psychology majors will also be 100. If they are different, well, we're still talking about the population mean for psychology majors. 100 is our reference point. But this would be a does not equal. This would be a two-tailed test because the question I asked earlier just asked if the psychology majors are different. All right then, so the second step of hypothesis testing is stating the rejection region. I've already identified this as a z-score. We know it's a z-score test, a z-test, because I have mu and sigma for reference populations. There's everything I know about the population, I know everything there is. When we know sigma, we do a z-test. All right, so for the rejection region, what else we need to know? We're doing a z, so that's right, I draw a z distribution. There's a 0 in the middle because I want to be able to envision it. It's two-tailed. The alternative is a two-tailed test, so I'm going to sketch it like that. Rejection regions are going to be in the tails, away from the center. The one thing I haven't done is, let's say alpha is 0.05. Haven't given a level of significance for this. Levels of significance is, I think it defaults to 0.05 unless you want to use 0.01 for some particular reason. So for a z-test, two-tailed alpha 0.05, the critical values of z are 1.96, sorry, negative 1.96, positive 1.96. So we're going to put it into words, reject the null hypothesis if either of these are true. The z obtained, the z we get, is less than or equal to negative 1.96, or if the z obtained, OBT, is greater than or equal to positive 1.96. Now for the third step, actually calculating the value of z that corresponds to our sample outcome. The formula is z equals x bar minus mu sub x bar over sigma sub x bar. This is where the results come in. This is where you would do the experiment, right? So we're setting up the hypotheses. This helps us think about the experiment. This, ahead of time, before we see any data, says when we're going to make decisions about rejecting the null hypothesis or failing to reject it. All that's done ahead of time, so we're not influenced by the data. So let's say for this particular problem, let's say the sample mean is 110 and the standard deviation is, let's say, 8. So what does that mean for us? Well, now we've got to do the hypothesis test. We've got to calculate the z. X bar is 100. I'm sorry, 110. Mu sub x bar, well, according to the central limit theorem, mu sub x bar equals mu, which in this case is 100. Sigma sub x bar, according to the central limit theorem, is sigma over the square root of n. So what do we have? Sigma is 15 over the square root of 36, because n is 36. So this becomes 15 divided by 6. 15 divided by 6 is 2.5. Can you see that way down there? All right. That goes there. Right? That's way over in the corner, right? X bar, mu sub x bar from the central limit theorem. Standard error, sigma sub x bar, also from the central limit theorem. We get those numbers. Now we solve for z. Z equals 10. 110 minus 100 is 10, divided by 2.5. Z obtained, this is Z obtained, then equals 10 divided by 2.5, 4.00. So our Z obtained is 4.00. The fourth step of hypothesis testing is making a decision and stating a conclusion. So the decision, I want to take this outcome, 4.00, put it back in my rejection region chart from step 2. 4.00 is going to be right there, right, way out in that tail. So what does that tell me, right? It tells me my decision is to reject the null hypothesis, and the conclusion. Whenever we reject, we have evidence. Pretend that says evidence. We have evidence. Whenever you reject, you start off with the preamble, we have evidence. What do we have evidence? We have evidence for the alternative. We have evidence that psychology majors are different from average. We can go further. How are they different? Right? This tells me they're different. It also tells me how they're different. Right? The outcome, the psychology majors are up here. They are significantly above average. So I would say we have evidence that psychology majors are significantly above average in intelligence.